Okay, now look at your textbook. I'll explain to you one by one based on your textbook. Look at page 114, the new chapter, chapter 6. So, in this chapter, you're only going to learn about growth in animals, their support system, their movement system. Their support system is just skeletal system. Okay, type of support in animals. I'll go through with you one by one because I'm not sure then you will understand what is stated in the textbook. Okay. What is the support system for animals? Skeleton is the support system. Okay, there are three types of support system, which is endo, exo, and hydrostatic skeleton. Endoskeleton is the type of support for all vertebrates. And what are vertebrates? Can you see? Mammals, amphibians, fish, reptiles, bird. Okay, including human. We are under mammal. Endoskeleton is made up of internal bones. It's made up of internal bones and cartilage. They play a role in, you see, this is the function of the bone. The function of the bones. So I want you to highlight the function of the bone. Support the body weight. Protect the internal organ. Maintain the body shape. And attachment for muscles. So highlight all this. Endoskeleton means internal bone, and it's for vertebrates. Okay, then you have exoskeleton. Exoskeleton is the type of support for most invertebrates. Consists of a outer layer, so meaning the bone is at the outside. Waxy, it means oily. It's a waxy and it is a hard. So over here you just add on, it's waxy and it's a hard. Chitin or shell. That means the bone is very hard and it's oily. Exoskeleton function the same function as every bone, is to support the body weight, maintain the body shape, protect the internal organ, and is the place for muscle to be attached. And these are examples of invertebrates, examples of exoskeleton. Okay, can next, hydrostatic skeleton. Hydrostatic skeleton is also for invertebrates. Remember, exo and hydrostatic are for invertebrates. With soft bodies such as worms, they do not have any bones. They do not have any bones in their bodies. These animals are supported by hydrostatic skeleton. The hydrostatic skeleton consists of muscular wall that encloses the body cavity, which is filled with fluid. It means, remember I told you hydro means water. Another name for water is fluid. Okay, it means that inside this organism there is fluid, there is water. Okay, there's like water-like substance, and it's the water that make the all this organism to move around, and it supports the shape of the organism. Okay, there is no bones and they are very, very soft. The fluid exerts pressure on the wall of the body in all direction, causing the animal body to be firm. The hydrostatic skeleton maintains control the animal's body shape. Hydrostatic skeleton also plays a role in movement of the animal. Okay, examples of hydrostatic skeleton. Okay, next you need to learn about exoskeleton size with growth. Now this part you're already learning all about types of skeleton, and then you learn the function of skeleton, which I just explained to you shortly in the previous video. I've already explained to you. The next you are going to learn is the growth in exo endoskeleton. Now first, what does growth means? You're growing, right? For endoskeleton, that means for all vertebrates, their organism will show a growth and their graph will look like this. Even we human, we are under mammals, right? We will show this growth. Let's say the time is months or years. We will show this kind of growth, whereby at the age of 2 years we will start growing rapidly. and then you will see the growth started to decrease and become horizontal. Why? Is because you stop growing um, once you become a young adult, you will stop growing eventually, right? So this type of graph, you call it as sigmoid shape. You call it as sigmoid shape. For exoskeleton, can you see the graph is completely different? So you're going to learn about the graph. Okay, I repeat again. Now what you're learning is the growth curve for both endo and exo. You are seeing as of the organism lifespan how their how their growth is. When the bones grow, they have growth as well, right? So you're seeing that. Okay, let's start from the beginning. Growth can be measured and observed by plotting a graph of growth unit against time. This graph is called growth curve. Growth unit can be measured in height, like for humans. Volume, let's say if it is hydrostatic skeleton, inside got water, right? So you just see how big, how small the space. Volume is mainly about space. Wet mass or dry mass. The growth curve that is formed shows growth phases, growth rate undergone by organism. Next page. Growth curve of all organism basically is sigmoid in shape. This is called sigmoid. So we fall under here. All vertebrates fall under here. All endoskeleton falls under here. Okay, at a very young age, they will have a very dramatic growth rate. When you are small babies, you are toddler, around 2-3 years old, you will start to grow drastically, right? But until you reach your young adult, maybe around 18-20 years old, you stop growing because you already reach your growth rate. Okay, so it's like an S shape. So this is called sigmoid shape. It is different according to the type of organism. However, the growth curve of animals with exoskeleton is different and unique. This is for exoskeleton. Before I explain it further, can you see this graph? It's like a step shape. A step shape. Over here is a curve. Usually we see graph is either a curve like this, or we see a straight line, right? Or we see maybe decrease line, something like that. But over here, can you see this graph is extremely different, and it's in a shape of a steps. This is for exoskeleton. Before we go into the explanation, let's just quickly study the graph. This is horizontal line. Okay, horizontal line means like this, vertical line means like this. I repeat, horizontal, vertical. Okay, the horizontal line means there is no growth. You see, horizontal part shows zero growth. There is no growth for horizontal, but the vertical part shows growth, but it occurs dramatically, meaning if there is supposed to be an increase, the increase will be like a curve, like a very slow growth, a curve. Okay, but this one, can you see, is straight line. So like within days you quickly grow so fast, and then you don't grow, then you grow, you don't grow, you grow, you don't grow. This is for exoskeleton. The growth curve of the animals with exoskeletons such as cockroach, grasshopper can be seen in stages. This is because the exoskeleton of this type of organism is made up of the hard chitin, which is unable to expand. Remember I told you just now the chitin is very hard. Okay, it's very hard. If it is hard, how to grow? Unless if it is soft, then it can grow, right? It can expand. This one, it's hard, so it cannot expand. So what do you think these insects do? The insects will shed their skin. Like yesterday, I posted a video of the tarantula shedding the skin. Why? Because it is covered with a hard chitin. The hard chitin means the outside bone, okay? In simple, it's the outside bone. The outside bone cannot expand. So what must it do? it must throw away the old bone, and then it form the new bone, and then it throw away the old bone again. So the process is repeated until the invertebrate become bigger. This characteristic will prevent the growth of the animal that have exoskeleton. Meaning which characteristic? The outside bone is very hard, so it prevents the animal from growing. So the animal must do something. What the animal do? It throw away the outside bone, form a new bone. To overcome this problem, this animal shed. Can you see this word? Shed. Shed the exoskeleton repeatedly until they reach adulthood. The process of shedding is called ateiasis. During ateiasis process, a new soft exoskeleton is formed under the old skeleton. Okay, this graph shows the curve of an exoskeleton. So over here, if you see this image, what does it tell? This is the old exoskeleton. This is the old exoskeleton. This old outside skeleton is very hard. It cannot break unless you go and step it lah. But for this animal, it cannot break, it cannot expand. So the animal cannot grow, the insect cannot grow. What it should do? It will shed the skin. Okay, it's actually shedding the bone. You don't say shed the skin, it's shedding the bone, because this is actually a outside bone, right? Outside exoskeleton. This is called the chitin. This is the new bone. Okay, and then again the process will repeat and repeat again until this insect become very big. Okay, the vertical part shows growth that occurs dramatically. That means this is the part where it is shedding its old exoskeleton and forming a new one. The horizontal part, zero growth. Why zero growth? Is because this animal is inside the old skeleton and they are trying to form. That's the time they are actually growing inside the old skeleton, trying to form a new skeleton. The vertical one shows that it shed the old thing and become a new one. The horizontal shows a zero growth. A new skeleton that is soft is formed below the old skeleton. Okay, I repeat again. You may be a little confused. Let me repeat again. Horizontal straight line means no changes. That means there is no growth. But during this phase, actually what is happening is inside the old exoskeleton, the insect is actually growing the new skeleton. This is another new layer. So it's growing. This is vertical line. So meaning this is the time where it will shed the old exoskeleton. It will try to leave the old skeleton and come out of it. So it's actually growing and it grows drastically. It happens very fast. That's why the growth is a drastic growth, a dramatic growth. And then it happens again. So maybe this is the first time it shed the skin. And then the second time it shed, you don't use the word skin. This is the first time it shed the bone, then the second time, then the third time, the fourth time. Now it becomes adult. So the process is repeated. Okay. During ateiasis, the animals with exoskeleton will suck in air to expand their body. Like a balloon, you put air inside the balloon will expand, right? So it will suck air to expand their body. The action of sucking the air will break the exoskeleton, because this exoskeleton is too hard. The insect cannot break it. So what it will do is it will suck the air. It will suck the air and become so big until it will break. Like balloon, if it blows so much of air, the balloon will expand until it bursts, right? The same way, the same concept. A rapid growth will occur to increase the size of organism before the new exoskeleton hardens. Animal with exoskeleton will always undergo a few stages. The ateiasis stage causes the animal growth curve graph to be step-shaped. So you must know the difference. Endoskeleton sigmoid, exoskeleton step shape. Okay, and so we are done with the growth curve for both endo and exo.